Okay, so I've not really done a video in a long time, and this is just a silly little observation. So I'm currently doing stuff using an IMU, and this is the BNO055 and an Arduino Nano, and I've also got one of the ICM 20948s with a Raspberry Pi, which I'm doing the same things with. And I've been following along with Paul McWorter's rather excellent tutorials on using an Arduino Nano with a BNO055. He goes into some of the mathematics really rather well. But I was getting really weird results, even tilt compensated, even just dropping his code as well as the code I'd been following along writing myself. The magnetometer was not reading well. So I bought myself a bunch of these little button compasses. And it's kind of working. That is pointing north. But I was trying to find out if there are big sources of magnetism in the room. However, when I bought them, I got a bag of 10. Now, there's only 8 here because the children made off with one each immediately. But I've just been having fun observing what happens when you have this many compasses. So if I take everything away, let's take these 3 compasses and a magnet, and let's make them all face this way. So first thing that happens with these compasses is if I take this one and make it face another direction. So those are all facing that way, and they're all keeping themselves that way. So I'll take this one that's facing the opposite way and bring it to match these, and it deflects. And in fact, if I take 2 of these, so if I put them together, they will slowly line themselves up. Let's line them up. There we go. So they'll line themselves up, North Pole to South Pole, basically. And let's see, I should be able to turn them now. They're affecting each other, so they're not being affected by the Earth's magnetic field. There we go. And so if there's 4 of these, 2 of those, bring them closer, and they reach an equilibrium. Just watch them. It's kind of fascinating to watch them. Ooh, are you gonna? Sometimes you have to tap them to loosen them. Is it gonna go? It's reached an interesting equilibrium. Let's add some more. That one's turning to face the same direction. So this one here, it's about to flip. Is it about to flip? It looks like it is. I've just been playing with these for a while and just finding out what makes them slowly flip around. Of course, I could just go and stick a magnet this end and they all line up with it. It's quite fun watching them slowly find equilibrium again. I've been finding it fascinating, this whole business. There we go. So if I turn it sideways, and let's go this way, so we get. So that's kind of an interesting one, because in theory, when I say sideways, the magnetic flux, I guess, is going this way. Swiping it down the middle, make them spin, or running it along the table underneath, get some fun and interesting effects. I don't know, I just find this fascinating. I mean, playing magnets is always fascinating. Having this many compasses is something I've certainly never experienced before. They were very, very cheap on, you know, your favourite online vendors. At least a couple of them have very cheap magnets, very cheap compasses. I don't suspect they're up for much. I wouldn't want to use these for navigation. They're a bit too cheap for that. And I think if I separate them, now this may be also because there's a lot of magnetic sources in my lab. They kind of vaguely, some of them find the same, what's supposed to be north. The others need a bit of tapping, bit of coaxing. I mean, that might be too close to that MacBook, which has some very strong magnetic sources in it. So I don't think I'd want to trust my life and try and navigate with these, but they're certainly a lot of fun to play with. So I recommend playing with these. As to my original goal of trying to work out what might be going right and wrong with this magnetometer, still to deal with that. And the other thing actually is, when dealing with a magnetometer, turning it into a compass, you have to tilt compensate it. And if you look, a lot of these compasses, they're tilt compensated merely just by the way they're balancing. So the way this is balancing on that pin, it makes it sort of tilt compensated. thought I'd share that. I hope you found that fun. Okay, bye.